So I'm very happy to be here. It's my first time for the Congress of SISFA. It's a pleasure for me to be here with you. And the topic of my presentation is physics for neuroscience, the analysis of the Huxley and Hodgkin model of the action potential. It is interesting thing that in 1952, Alan Hodgkin and Andrew Huxley, two physiologists working in Cambridge, British physiologists, they have published the first quantitative description of the electrical excitability in nerve cells. And this publication is a cornerstone of electrophysiology and neuroscience, since it is the particular example of the use of physical laws and scientific model within life sciences. In some way, we can say that it is the birth of the modern biological research based on quantitative models. In 1963, Hodgkin and Huxley, with John Eccles, they won the Nobel Prize in physiology or medicine. So the basic general background of my topic is the case of the role of models and physical laws in scientific explanation if referred to life sciences. In recent literature, for those of you who are maybe friends of the philosophy of science contemporary, within the so-called new mechanical philosophy, there is the interesting paper of Carl Craver, American neuroscientist, who wrote the paper about use of scientific models. And in that paper, he argued that this model is the example of non-explanatory model, merely phenomenalist model, where we deal with the use of mathematical equations, but without explanation of underlying causal processes. So in my talk, I would like to, on the one hand, counter-argue the interpretation of that model presented by Carl Craver, and on the other hand, I would like to point out the essential role of physical laws that are present in Hodgkin and Huxley model of the action potential. So my main focus is on the paper of Hodgkin and Huxley from 1952. It is a beautiful paper in which, on the one hand, we can see the core of experimental aspects present in their research. So from 1939, Hodgkin and Huxley, they have studied action potentials in the relatively huge axons of the squid oligoformesin. It is one of the common squids that is present near to the United Kingdom, and it has the mantle length of 90 centimeters and the diameter of axons of 1 millimeter. So choosing this physical model to do their research, they have succeeded in inserting microelectrodes into that axons in order to do their research. Moreover, they have applied for that time a very innovative experimental technique of the voltage clamp. Basically speaking, it enables to freeze the neuron at particular voltages in order to measure the current and also the resistance of the axon. So applying these two experimental aspects, they obtained the vast amount of empirical data. And when we look at the main theoretical aspects of their model, we can say that in very elegant form, it shows that the process of depolarization of the squid axons triggers rapid current carried by sodium ions, then followed by a more slowly outward current of potassium ions. And they noted that there is the voltage dependence of gate positions and channel conductance. And they provided the main intuition that is in the background of their theoretical analysis of the process of the action potential is that we can divide the total membrane current into on the one hand, on the right side, the first element is the membrane capacity. It means the first element on the right side. It means that the current into a membrane is proportional to the size of the membrane, of the capacitance of the membrane, and the rate of change of the voltage across it during the time. And the second element on the right hand, it says that we deal with various ionic currents. And they provided the description of that various ionic currents, divided it into sodium, potassium, and other ions currents. So if we refer, for example, to the case of potassium current, we can say it is the equation taken from the paper from 1952, that the current in this case of potassium is equal to the product of conductance and voltage difference. And they measured the voltage difference putting the modification to the Ohm's law, because we can see that the first equation is just derived from the Ohm's law of electricity. And in the second equation, we can see that the factor of the right hand is the modification of the Ohm's law, where we deal with the so-called driving force on the ion. And that formula is derived from the use of Nernst equation applied to the membrane capacity and voltage. Further, very important theoretical aspects of the model is that they applied also the statistical approach to deal with the movement of potassium and sodium ions in the vicinity of the membrane. I refer to the case of potassium ions, that they explain that the actual conductance on the left side is the proportion of the maximum available conductance of potassium ions. And they introduced the variables here, n and h, that are providing the mathematical representation of the probability of certain gates being opened or shut when we deal with the conductance across the membrane. So all these theoretical elements, collecting above all these theoretical assumptions, they have expressed in the equation of the total current as a function of time and voltage, when we can see that we have the first element on the right side, it is the membrane capacity, and then representation of specific currents, ion currents, of potassium, sodium, and leakage currents that represent all other ions moving across the membrane. So my focus, as I mentioned, is to I'm trying to answer what is the role of laws, of empirical physical laws, as they are present in the construction of this model of the action potential. So first of all, we can see that in an elegant way, this model links the microscopic level of ion channels to the macroscopic level of action potential and current. And we can see that physical laws play the crucial role since they are securing that quantities present in the equation can be measured, and then are effective in predicting and explaining the vast class of phenomena linked to the action potential. Moreover, cell membranes are treated as capacitors that storing opposite charges on the intra and extracellular side. Of course, they deal with the description of various ionic currents present in the phenomenon of the action potential. And the basic assumption in the background is that we deal with the movement of charged particles in an electric field. Also, we can note, reading that crucial paper from 1952, that they are explicit about idealizations present in the elaboration of the model. That on the one hand, they treat neurons as ohmic conductors, and on the other hand, membrane capacity is behaving as the perfect condenser. And also analyzing equations present in that model, we can see that we can discern that there are two types of equations. First of all, they apply essentially empirical equations based upon the equations that describe the movement of a charged particle in an electric field. These are equations that are in the foundation of that variables n and h that are describing the probability of gates being open or shut. But also, as I mentioned before, they are equations directly based on the application of the Ohm's law and Nernst equation to represent the action potential. So maybe it can sound a bit trivial, simplistic, but I think it's very important to emphasize that the use of the empirical laws in this model is expressing how things are. They apply physical laws of electricity to ascertain, to describe what is going on. These laws are not doing the work of explaining why things are going in this way, but that something is the case. And in a quantitative form, this application of electricity laws, it's enabling them to describe in a good, adequate way the process of the action potential. So as I mentioned recently, in the literature of the new mechanical philosophy, there is the interpretation of this model as the purely phenomenal one that not able to go beyond the mere description of what is going on, not able to give the insight into the causal process going beyond. And in that paper that I mentioned at the beginning of Carl Craver from 2006, Carl Craver is referring directly to two passages from the paper of Hodgkin and Huxley. And indeed, these are two most important passages to do such an interpretation. That in the first passage, it is at the beginning of the paper, Hodgkin and Huxley are quite explicit that they have no evidence in favor of the mechanism of permeability. They are wondering what are molecular details of that process, and they have no evidence. So that's why they are thinking that maybe there is the hypothesis of charged particles carrying sodium or potassium ions, and they invalidate that hypothesis because they see that there is the sort of extreme steepness and speed of propagation, the relation between conductance and membrane potential. So that's why then they express their judgment that sodium movement depends on the presence of charged molecules, but which form a bridge or chain which allows sodium ions to flow through the membrane when it is depolarized. Details of the mechanism will probably not be settled for some time, but it seems difficult to escape the conclusion that the changes in ionic permeability depend on the movement of some component of the membrane, which behaves as though it had a large charge or dipole moment. So one may ask, if they have no evidence in favor of precise mechanism of permeability, why at the same time they claim that it is difficult to escape the conclusion that permeability depends on the movement of some components of the membrane. So reading the paper and seeing the content of the paper, we can note that in the background, there is this fundamental idea that they deal with charged particles. They try to represent the movement of charged particles in an electric field, and the rapid development of the process means for them that there should be the change in the membrane, that it is the clue to reason about the molecular details of that process. So while reading Hodgkin and Huxley paper, that they write themselves that they have no evidence in favor of precise mechanism of permeability, I think that we should discern two meanings of the word mechanism as it is employed in their paper, but also in some philosophical comments, as it is in case of, for example, the paper of Karl Kramer. But the concept of mechanism, on the one hand, it refers to things that are out in the world, to some process in the world, okay. But on the other hand, this term refers to a model theoretic construction. So if we think about their model, okay, they have expressed that in some way they model mechanism that they are trying to represent is like a placeholder, it's like a black box that is needed, that needs a further filling in, that needs a further explication of the elements and the organization inside. So if we look in this way at this model and the development of the theorizing about the model of the action potential, I think that it is good to discern at different stages of the work on that model. On the one hand, the framing stage, in the sense that there is a set of alternatives in the case of this model. As I mentioned, they hypothesized about various molecular mechanisms. They invalidated one and they opted for another one. There is the ascription of certain values to the variables that they presented in that model, NMH, that variables dependent upon the probability equations. So there is that set of alternatives, and they are trying in some way, in a coarse-grained way, describe what is to be explained. Then also we see that there is the difference-making stage, in the sense that they try to provide a causal explanation of the explanandum because they refer to different ionic currents. They discern four main components. They represent the increase of the membrane potential. They describe the wide range of the phenomena that are empirically confirmed. So there is well explicated the difference-making stage. And finally, there is also the representation stage, in the sense that they are explicit about some idealizations that I already mentioned present in their model. So going to the end, if someone is forcing the phenomenalist interpretation of this model, I think that it is based on, not grounded in their paper, in the research, some tacit assumptions present in such a position. That first unwarranted assumption, it will be that always explanations and descriptions should proceed hand in hand, in the sense that the role of empirical laws is interpreted as the role of understanding or explaining why of the phenomena, rather than describing or ascertaining the phenomena. The second unwarranted assumption is the assumption that the sort of black box or unfilled term, non-understanding yet some terms in the model, is based on the assumption that it is completely unilluminated black box or completely unilluminated mechanism or model. But as shows the case of empirical confirmation, it is not the case, because the lack of evidence for some molecular details in case of their model, okay, there was the lack of evidence, but it stood as a good placeholder for the future work, for the future elaboration that has arrived with next generations of scientists. This model, I think that it lays in a range of how plausibly models, but empirically confirmed that to a certain degree of adequacy, it is well confirmed. And finally, there is the unwarranted assumption that of unqualified requirement of causal completeness, that only model which is causally completed, it's explanatory one. So I also think that, as shows this case, it is unwarranted assumption about the good deal of adequacy of scientific models. So thank you very much. Se ci sono le domande,
Italiana.
possiamo in italiano.
Grazie mille, posso English italiano.
Italiano, sì, va bene.
Il mio è più che altro un commento, perché a proposito di questa distinzione tra il fenomenologico, esplicativo, esplanatorio, eccetera, mi sembra che sia abbastanza simile alla differenza che si può tracciare tra il carattere delle leggi di Congresso, per esempio, e il carattere delle leggi di Newton. Cioè, normalmente si dice che le leggi di Newton forniscono una spiegazione, laddove invece le leggi di Congresso sono solamente una descrizione, se ho capito bene anche da... Tuttavia mi sembra ci sia un malinteso di fondo nella critica che fa Craver, nel senso che le ipotesi per definizione non sono dimostrabili. Cioè le ipotesi sono un punto di partenza, diciamo, che delle affermazioni, insomma, su grandezze, diciamo, ritenute rilevanti, da cui poi vanno dedotti i fenomeni osservati. Quindi non capisco cosa c'è che non va, nel senso, in questo modello. Cioè, da caso, si è capito tempo fa che andare all'indietro all'infinito, cioè lo stesso Newton non fornisce una spiegazione delle sue ipotesi, cioè la validità delle ipotesi risiede delle deduzioni che si possono fare. Quindi io non mi è molto chiaro cosa si aspetterebbe Craver, diciamo, da un modello in generale, cioè cosa vorrebbe. Cosa se è chiaro dal suo articolo, visto che diciamo ovviamente non ce l'hai descritto tutto, però se si capisce meglio cosa vorrebbe da questo modello.
Allora, mettendomi nelle scarpe di Craver, direi che si aspetterebbe da un modello che, se un modello sta, direi, realizzando alcune condizioni di essere un buon modello esplicativo, si aspetterebbe che facesse anche il lavoro di spiegare i processi causali. Cioè, questo è un po' la traccia che sta mettendo Craver, che cerchiamo da un modello di dire quali sono anche le cause dei processi. E invece lui sta facendo interpretazione di questo modello di Hodgkin e Huxley, che secondo me, e questo è il mio focus, dal punto di vista storico, non regge bene, nel senso che lui sta aspettando da un modello qualcosa che, cioè, in qualche maniera non realizza secondo le condizioni che Craver mette per un modello, ma dall'altra parte questo modello già mostra le buone intuizioni, secondo le aspettative di Craver, di andare verso la spiegazione causale. E Craver trascura questo aspetto perché mette un ideale che secondo lui non viene realizzato da questo modello. E in questo senso direi che è importante conclusione per un filosofo della scienza che legge attentamente in qualche maniera ciò che sta nel testo senza forzare un po' le sue aspettative, la sua interpretazione.
Una cosa, perché mi hai chiarito un dubbio che come sai portavo dietro rispetto a questo paper di Craver, E in effetti, tornando all'essere originale di Hodgkin e Huxley, cogliamo c'è un'intenzione proprio totalmente differente anche degli autori originali. Ma hai trovato in letteratura, nella ricezione proprio della tesi dell'originale, no? Di Huxley e Hodgkin, altre interpretazioni magari alternative? C'è qualcuno che ha rispettato la lettera, gli autori originali, gli scenari originali? O in effetti il loro caso è stato interpretato in un altro modo, andando anche, diciamo, vedendo le intenzioni originarie? Hai trovato altri, oltre a Craver, che hanno legittimato
sì.
Perché questo è un caso, secondo me, emblematico di distorsione di come sono avvenuti i fatti, di come erano le interpretazioni originarie.
L'unico è Jim Bogan, che in paper dedicato alla regolarità della causazione sta facendo anche alla maniera di Craver, interpretazione che è meramente esplicativo uso delle leggi scientifiche, delle leggi della fisica, ma allo stesso tempo Bogan sta scrivendo che almeno usare queste leggi, e qua si differenzia da Craver, ha aiutato a loro a mettere le costrizioni spaziali e temporali dei processi che stavano descrivendo. Cioè, in questo senso Bogan è fedele ad interpretare l'uso delle leggi non in quanto esplicative come ipotesi, teoria, ma in quanto ammettendo le costrizioni, constraints, per poi andare avanti con la ricerca. Cioè, lui non ha portato poi avanti alle conclusioni che io cerco di portare, ma almeno ha messo in luce questo, in maniera differente da Craig.
Okay. Altri casi non hai trovato in discussioni? Chiaro che dentro il neomeccanicismo, però questa roba che hai tirato fuori per il castello dei neomeccanicismi.
Sì, perché loro hanno scelto propriamente questo modello in modo di interpretarlo in maniera fenomenale come un punto di partenza, per far discernere tra modelli fenomenalisti e modelli esplicativi. Sì, questo sì.
Diciamo un attimino che si è rilevante. La medicina antica, che io sappia, era basata su quello che hanno cercato di iniziare a fare Hodgkin e Huxley, cioè nel senso che io sappia, diciamo, nell'antichità si era provato a fare una medicina, quindi in qualche modo life sciences, con un metodo che fosse ipotetico e deduttivo. Quindi diciamo un esempio senza precedenti.
Insomma, è molto complesso. Come anche qua, la linea aristotelica, quella galena. Però, insomma, sì.
Va bene.
Se posso, alla fine faccio piccola pubblicità, che lavoro all'Università di Torun, abbiamo un gruppo di ricerca logica e filosofia della scienza e in ottobre organizziamo conferenza su ipotesi nelle scienze, perché uno potrebbe chiedere ma come mai uno che viene dall'Università di Niccolò Copernico non parla niente di Niccolò Copernico? No, lo parlerò, ma lo parleremo durante la conferenza. Allora già oggi vi invito fortemente, oppure partecipazione online, oppure prossimo anno sarà un giubileo di 550 anni dalla nascita di Niccolò Copernico. Saranno grandi congressi in Polonia, grandi conferenze, e considerando che siete della società di Ecco, allora vi invito fortemente a fare contributo, a partecipare in questi eventi. Flava Marcacci fa parte del comitato scientifico, siamo molto fieri, contenti, allora vi invito a seguirci.
Grazie.